Black hole. A black hole is anything but empty space. Rather, it is a great amount of matter packed into a very small area. Think a star 10 times more massive than Sun, squeezed into a sphere approximately the diameter of New York City. The result is a gravitational field so strong that nothing, not even light, can escape. The idea of an object in space so massive and dense that light could not escape, it has been around for centuries. Most famously, black holes were predicted by Einstein's theory of general relativity, which showed that when a massive star dies, it leaves behind a small dense remnant core. If the core's mass is more than about 3 times of the mass of the Sun, the force of gravity overwhelmed all other forces and produced a black hole. Scientists cannot directly observe black holes with telescopes that detect X-ray light or other forms of electromagnetic radiation. If a black hole passes through a cloud of interstellar matter, for example, it will draw matter inward in a process known as acceleration. If the total mass of the star is large enough, about 3 times the mass of the Sun, as the surface of the star near an imaginary surface called the event horizon. When the surface reaches the event horizon, time stands still and star can collapse no more. On the other end of the size spectrum are the giants known as supermassive black holes. Black holes, which are millions, if not millions of times as massive as the Sun. Astronomers believe that supermassive black holes lie at the center of the virtually all large galaxies. Observational evidence indicated that all or nearly all massive galaxies contains a supermassive black hole located at the galaxy's center. In the case of Milky Way, the supermassive black hole corresponds to the location of Sagittarius A at the galactic core. A black hole is a region of space-time exhibition such a strong gravitational effect that nothing, not even particle and electromagnetic radiation such as light, can escape from inside it. The comparatively small mass of this black hole, along with the low luminosity of the radio and infrared emission lines, imply that the Milky Way is not a Seyfert galaxy. Ultimately, what is seen is not the black holes itself, but observations that are consistent only if there is a black hole present near Sagittarius A. Astronomers can detect them by watching for their effects on nearby stars and gas. Scientists managed to accomplish this feat by focusing their attention on objects located about 30 million light years away from Earth, as due to the time it takes light originating from there reach our planets. It is remarkable that such massive dense objects were able to form so soon after the Big Bang. Astronomers had discovered what may be the most massive black hole ever. Small galaxy about 2.5 million light years away from Earth. Scientists say the supermassive black hole has a mass equivalent in the scenery at the threshold of an Earth-sized black hole. If you had a black hole the size of our solar system, then the tidal forces at the event horizon are not quite that strong. Radiation in space takes the form of subatomic particles from the Sun as well as from resources in the Milky Way galaxy and beyond. Observable universe is the spherical region of the universe comparison all matter that can be observed from Earth or its space-based telescopes. Exploratory probes at the present time allows electromagnetic radiation from these objects has had time to reach the solar system and Earth since the beginning. Health threats from cosmic rays is the danger posed by galactic cosmic rays and solar energetic particles to astronauts on interplanet. Space radiation threat to astronauts explained. Infographics. Humans traveling beyond the protection of Earth's atmosphere and magnetic field risk radiation cause cancer and other diseases. The model of the universe contains dark energy in the form of a cosmological content. This theory suggests that only gravitationally bound systems, such as galaxies, will remain together and they too will be subject to heat death as the universe expands and cools. The Big Bang. Most astronomers believe the universe began in a Big Bang about 14 million years ago. At that time, the entire universe was inside a bubble that was thousands of times smaller than a pinhead. As the universe expanded and cooled, energy changed into particles of matter and antimatter.
Hold me close till I get up. Time is barely on our side. I don't wanna waste what's left. The storms we chase are leading us, and love is all we'll ever trust. Yeah, no, I don't